Good morning, or hello. It doesn't matter. I don't know when you're going to watch this, but whatever. Today we are going to move to chemistry booklet number 2. Okay, so this is all about bonding, and we're going to be doing a abbreviated version. So don't worry, we're not actually going to get through this whole booklet, but we are going to get through covalent and ionic bonds. Okay, so open it up, and you're going to need your periodic table that you colored in the other day, and some pens. Okay, so there's 2 types of bonds that we're going to be learning about, covalent and ionic bonds, and we're going to start with covalent bonds first. Okay, so a little bit of background here. Covalent bonds form between nonmetals and other nonmetals. Okay, so if you are a nonmetal, so anything to the right of this staircase here, and hydrogen, you can form a covalent bond. Okay. All nonmetals want to, maybe I'll change my color here. All nonmetals want to gain electrons and they want to form anions. Okay, and anions just means negative ions. Okay, so what that means is when it means that they are short so many valence electrons. Okay, and I'll explain that a little bit more in a little bit. Okay, atoms want to share electrons to get a full outer shell. Okay, and a shared pair is represented with a single line. So I'm going to show you some examples here. This is why drawing our Lewis dot diagrams and feeling comfortable with that was going to come in handy now. Okay, so we're going to take a look at what would happen if we wanted to bond 1 nitrogen and 3 fluorine. Okay, so the first thing I need is I need my periodic table, and I'm going to find nitrogen here, and I need to figure out how many valence electrons nitrogen has. So I'm going to go to the beginning of the row, and I'm going to count across 1, 2, 3, 4, 5. Okay, so nitrogen has 5 valence electrons. Okay, 1, 2, 3, 4, 5. Okay, and I'll write that also here. I'll make it a lot bigger. Okay, now what about fluorine? Okay, where's fluorine? Over here? Okay, so I'm going to back it up to the beginning of the row, which is here. 1, 2, 3, 4, 5, 6, 7. Okay, so fluorine has 7 valence electrons. Okay. So 1, 2, 3, 4, 5, 6, 7. Okay. So now I'm going to draw that here. 1, 2, 3, 4, 5, 6, 7. And you notice here that we have a pair of electrons that can match up. Okay, so this fluorine and that, or this electron from fluorine and that electron from nitrogen are going to share valence electrons. Okay, we'll do the same thing here. Now I'm going to put my lone one there to make drawing this easier. Okay, so 7 valence electrons, and nitrogen, that electron and that electron are going to be shared, and the same thing with this 3rd fluorine. Okay, these 2 are going to be shared together. Okay, now do we have to draw all of this all the time? No, if we know which ones are going to be shared, we can abbreviate this by writing it like this. Okay, so it shows that it's sharing a single bond, a single bond, a single bond. And a single bond just means it's sharing 2 electrons. Okay, because the goal of every element is to become like its closest noble gas. Okay, so fluorine wants to become like neon. Okay, neon has 8 valence electrons, so in order for fluorine to become like neon, it needs 1 more valence electron. That's why it gains, where we said here that all nonmetals want to gain electrons. Okay, so they want to gain electrons to become like their closest noble gas. Okay, what was the other one we had? Nitrogen. Okay, nitrogen is right here. It wants to become like neon. It needs 1, 2, 3 more valence electrons to become like neon. Okay, so if we look here, nitrogen needed 1, 2, 3 electrons in order to become stable. Okay, right on. Now, what happens if we looked at just fluorine and a fluorine together? Okay, so we already know that fluorine has 7 valence electrons. Okay, so when we rewrite this, we can just draw the 1 single bond between fluorine, the 2 fluorine molecules. Okay, and you see this term, it says F2 is a diatomic molecule. So what that means is that in this molecule, this fluoride molecule, there are always going to be 2 fluorines. Okay. Now, there are 7 elements that are diatomic. That means they're never alone. Okay. You never find them by themselves. They're always with another one of themselves. And they start at number 7. They start at nitrogen and they make a 7. Okay, so nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So see how it makes like the number 7 here on the periodic table. So what I'm going to do is I'm just going to put a little star next to them to help me remember which ones are diatomic. Okay, so that means bromine will never be by itself. It'll always be Br2. Iodine, I2. Chlorine, Cl2. F2, oxygen, O2, nitrogen, N2, and not carbon. That's as far as it goes. Okay. Okay. Next one, sulfur and 2 chlorines. Okay. So if I take a look, here's sulfur and chlorine. I'm going to zoom out just a little bit so I can see the whole periodic table. How many valence electrons does sulfur have? Okay, start here. 1, 2, 3, 4, 5, 6. Sulfur has 6 and chlorine has 7. Okay, so on my picture here, I'm going to add my 6. 1, 2, 3, 4, 5, 6, and then 7 for chlorine. 1, 2, 3, 4, 5, 6, 7. Okay. So sulfur here, it only has 6. That means it needs 2 valence electrons to be stable. And chlorine has 1 that it needs, right? So that's why if we have 2 chlorines, then sulfur is going to get to share 2 sets of electrons and be able to be stable. So I'm going to draw this out once more so we can visually see that. So there's my 7 valence electrons for chlorine. And here are my 7 valence electrons for chlorine on the other side. And then sulfur is going to be in the middle. And I just rearranged my valence electrons to make it easier to see which ones are being shared. Okay, I still have 6 here. So this valence electron is going to share that valence electron with chlorine. So they both have an extra 1, and then they're going to share this pair here. So now sulfur has 1, 2, 3, 4, 5, 6, 7, 8. Chlorine has 1, 2, 3, 4, 5, 6, 7, 8. And this chlorine has 1, 2, 3, 4, 5, 6, 7, 8. So they have become stable like argon. Okay. And then the shorthand for this would be Cl-S-Cl. Okay. And then we have carbon and fluorine. Well, fluorine we already know has 7 valence electrons. And carbon has, let's see, there it is. Back it up. 1, 2, 3, 4. Carbon has 4 valence electrons. Okay. 1, 2, 3, 4. Okay, so in order for carbon to become stable like neon, it needs another 4 valence electrons to get 8. Okay, fluorine has 1, it needs 1. Okay, so that's why if we have 4 of them, we're going to be able to have 1 set of valence electrons shared between each pair. Okay, so 1 shared here, 1 shared here, 1 here, and 1 here. And as a result, they will all now be stable. Okay, so that's how kind of the bonding part works with covalent compounds. Okay, the big thing is that they share. They have to be all nonmetals and sharing. That is key. Okay, now how do we name them? What do we call them? Okay, how to name covalent bonds. And I like this. I think this is really interesting how they do this. Okay, and not that complicated too, and I'm not making you memorize anything. I give it all to you. Okay, so how to name covalent compounds. Okay, here we go. So prefixes are used. Okay, and if you're like, what's a prefix, Miss Labiuk? Okay, well, think about, I'm just going to write a note here. Think about Mr. and Mrs. What comes before a name? Okay, that's what a prefix is, something that comes before a name. Okay, so prefixes are used to show how many atoms of each element are in a compound. Okay, the I, D, E ending is still used. Okay, and all that means is that these compounds end in IDE. So I'm going to write that here. These compounds end in IDE. Okay, so we take a look. If we have 1 of something, it's mono. Okay, if we have 2 of something, it's di. 3 is tri. 4 is tetra. 5 is penta, and it goes up from there. And if you look on your, you had a larger periodic table, and it had a list of all of these prefixes that went all the way up to 10. Okay, so let's give it a try here. Okay, remember that's why this little thing here. It says mono is never used on the first element. So we put these prefixes in front of each element except for mono. Okay, so let's see here, P2S5. Okay, so what does P stand for? Okay, so P stands for phosphorus, right? If you find it on your periodic table here, or it has to be over here. Okay, so P stands for phosphorus. So I'm going to have phosphorus. And S stands for sulfur. Okay. Okay, and now I'm going to look here. We have 2, which means di. Okay, so I'm going to have diphosphorus. Okay, so this 2 means di. Okay, and then 5 means penta. So in front of sulfur, I'm going to have penta. Okay, so this 5 means penta. Okay, and then we also have to change the ending. So you get rid of the last couple letters. So here is going to be the U and the R, and then we replace it with IDE. Okay, so it's going to be diphosphorus pentasulfide. 2 separate words. Okay, let's try another one. Okay, AS2O4. Okay, what does AS stand for? Come to your periodic table. AS, here we go, arsenic. Okay, So arsenic, okay. And what does O stand for? Oxygen. Okay, now let's do our prefixes. Okay, 2 di. Okay, so we're gonna have diarsenic. Okay, so here the 2 helps us, tells us how many arsenics we need. And then 4 is penta. 4 is penta. Oxygen. Okay, but we need to get rid of the last few letters, and with oxygen you get rid of everything from Y on, okay? And we replace it with IDE, okay? So here we would have, this would be pentasulfide, and this would be pentaoxide, okay? What letters do you remove at the end? I try and sound it out in my head. There's no real rule for this. It's normally the last 2 or 3. Oxygen is the last 4, but normally it's the last couple. When you try and say it out loud, you'll see what sounds right. Okay, so diphosphorus pentasulfide, diarsenic pentaoxide. Okay, and now let's take a look at the last one here, CO. Okay, so C stands for carbon. Okay, O stands for oxygen. Okay, and how many carbons do I have? Well, there's no number here. So because there's no number, it means 1. Okay, we don't have to write the ones. If the element is there, it means there has to be at least 1. So because there's 1, that would be mono. Okay, but remember, we never put mono on the first prefix, so we don't have to write anything here. Okay, but we do write it on the second one. So carbon, mon, O is right there. We don't have 2 O's next to each other. And then we change the ending, IDE. Okay, so this would be monoxide. Oh, look at that. Something you've heard before. Carbon monoxide. CO, carbon monoxide. That's how it gets its name. Okay, so notice how there is no prefix here. Okay, right on. So that's how you name them from their formula, okay? Now, try these ones. Now we have the name. Let's go back and put it into its formula, okay? So here we have carbon, so that's going to be C, okay? And then I have dioxide. Oh, look at this. Di, here's my prefix. I can figure that out. So that's going to be 2. And oxide, well, I don't count the IDE, so I'm left with oxygen. Okay, so di, 2 means I put a subscript little 2 after the O. I can write C1O2, but you don't have to. You can just be CO2. Okay, and that's what carbon dioxide is. I'll write that here. You don't have to write the 1. Okay. Next one, dinitrogen trisulfide. Okay, so di, there's my prefix, and tri, here's my prefix. Okay, so if I look at the rest of this, I have nitrogen. Well, that's going to be N. And there are 2 of them, so it's going to be N2. And now trisulfide, well, I don't need the IDE, but that's going to be sulfur, so that's S. Okay, and then tri means 3. Okay, N2S3. Okay, so here is where the di went, and then here is where the tri went. Okay, so note, okay, subscripts, okay, that's these little numbers. must be written slightly below the element symbol. Not beside. Okay, that's really important. If you just had N and then a big 2, S and then a big 3, that acts more like a coefficient and tells us how many of that compound there are. Okay, and we don't want it to have it too high, because then that tells us what the charge is. So where this little subscript is really important. Okay, turn the page. Okay, write the names for the next 3. Okay, give it a try. I'm going to pause. I'm going to write the answer. You're going to try it. I'm going to write the answer. We'll see if we get the same thing. Okay, write the names for P, BR3. Pause your video. Okay, phosphorus tribromide. There's the 3, there's the 3, here's the change in the ending. Okay, next one, write the name for CO2. Go. Okay, carbon dioxide. We don't have to write mono, right? We don't write that for the first one, but here's my 2. So there's my di, and then here is my new ending. Okay, and the last one, CF4. Okay, carbon tetrafluoride. There's the 4, there's the tetra, and here's our different ending. Okay, right on. And notice how these are all nonmetals. There's no metals involved at all. Okay, covalent bonds are only nonmetals. Okay, try it the other way around. Write the formulas for phosphorus pentasulfide. Go. Phosphorus is P, penta is 5, sulfur S. Okay, next one, nitrogen monoxide. Go. Nitrogen, no prefix, so I know there's just one. Mono, so I know that's just going to be 1, and oxygen will then just be an O. NO. Next up, carbon C, no prefix in front, so I know that's going to be 1. Tetra, oh, that's going to be 4. And iodide, okay, that's iodine. There we go. Okay, excellent. Hope you're feeling a little bit more comfortable with this. Okay, I want you to watch the other video, and we're done. Thanks.